What if you could travel at the speed of light? Imagine the possibilities. As you ponder this, let's unpack the concept. The speed of light, a staggering 299,792 kilometers per second, stands as the universe's ultimate speed limit. This boundary isn't just a number, it's the edge of human aspiration, blending the rigor of scientific inquiry with the boundless creativity of science fiction. It's where reality meets imagination, sparking the curiosity of dreamers and scholars alike. Now let's dive into what it would mean to defy this cosmic speed limit. To understand light speed first, we need to talk about Albert Einstein. Albert Einstein, one of the most brilliant minds of the 20th century, radically transformed our understanding of the universe with his theory of relativity. At the heart of this theory lies a fascinating concept. As you travel faster, closer to the speed of light, time itself begins to stretch and bend. Imagine you are on a train moving at an incredible speed, almost reaching the speed of light. To an observer standing on the platform, it appears as though everything on the train is happening in slow motion. This phenomenon is what Einstein described as time dilation. It's like watching a slow-motion video compared to real-time events. This means that for someone traveling at such high speeds, time would pass slower for them compared to someone who remains still. A trip that feels like minutes to the traveler could actually span years on Earth. So, traveling at the speed of light could theoretically turn minutes into years. Achieving light speed, however, presents some formidable challenges. Imagine trying to push an object to the speed of light. As it accelerates, it gains mass. This isn't just any mass increase, it's an exponential surge. According to Einstein's theory of relativity, as an object moves closer to light speed, its mass approaches infinity. To propel such a massive object, you'd need an infinite amount of energy. It's a cosmic catch-22 that currently places the speed of light just out of our technological reach. Even with the most advanced technology today, we only manage to nudge subatomic particles to near light speeds using enormous particle accelerators. These machines, like the Large Hadron Collider, stretch for miles and operate under extreme conditions, yet they only scratch the surface of what would be required to propel larger objects, or, dare we say, humans at light speed. Clearly, our current technology isn't ready to push us to the speed of light, but what if it were? Imagine for a moment a spacecraft capable of light speed travel. This isn't just a fantasy from the pages of a science fiction novel, it's a gateway to the universe unfurling before us. As we embark on this hypothetical journey, the rules of time and space begin to warp. Astronauts aboard would experience time dilation, a phenomenon where time, as measured by someone moving at the speed of light, slows down relative to someone on Earth. Now picture this, while mere minutes might pass for our travelers, years could unfold back on Earth. This bizarre consequence of Einstein's theory of relativity paints a poignant picture of isolation in the vast cosmic arena. Communication, too, would lag, creating echoes across space-time, messages sent and received with years in between. Should this spacecraft reach the distant stars or even other galaxies, the implications are profound. Imagine setting eyes on uncharted alien worlds or witnessing the swirling galaxies up close. The universe could shrink dramatically, bringing distant celestial bodies within our reach. While the speed of light remains a distant target, the pursuit of this boundary pushes the limits of our understanding. In this exploration, we've traversed from the realms of pure imagination through the profound insights of Einstein's theory of relativity. We've grappled with the immense technological challenges that confront us as we dream of traveling at the speed of light. Each step on this journey, from the theoretical equations to the engineering hurdles, brings us closer to what was once thought impossible. Imagine the cascade of breakthroughs that might follow a successful attempt to achieve light-speed travel. The implications stretch far beyond the stars, influencing everything from interstellar travel to the fundamental principles of physics and even time itself. This pursuit, however ambitious, is not just about reaching a staggering velocity, it's about expanding the frontiers of science, testing the limits of human ingenuity, and redefining what's possible. Whether or not we ever reach the speed of light, the journey there will continue to illuminate dark corners of science and imagination.